So this evening I'll go through a couple examples from in class. Unfortunately I don't have Mole Mountain with me, so I can't redraw it, but I will try to do my best here to explain things clearly. So now we're only going to use S and P of the GRASP problem solving method, so we're not going to go through all the different details. The first step is to write down what the question tells you. So I see that I have 5.0 moles. Sorry about that. So I see that I've got 5.0 moles. And I need to figure out from this question the amount of molecules. So what I'm looking at here is I know that molecules is the next thing I'm going to need. So that's the big thing that I'm going to look at next. So to go from moles to molecules, what I'm going to do is I'm going to need to go times 6.02 times 10 to the 20. Alright, so how many moles of NO2 are in the sample it contains? So the first thing I'd write down is I'd write down what is given to me. So let's start out with 7.521 times 10 to the 23 molecules. So the first thing I need to do is I need to get over to moles. So what I know is I know that Avogadro's number would be great to use here. So we'd use 6.02 times 10 to the 23 molecules per mole. My molecules would cross out, and if I said 7.521 times 10 to the power of 23 divided by 6.02 times 10 to the power of 23, I would get, and I'm going to write out to 4 significant digits, 1.248 moles. And sorry if my 8 isn't great there. So now I need my therefore statement. So therefore, there are, I go back up to the top and look at my significant digits, 1, 2, 3, 4 significant digits, 1, 2, 3, 4, my answer, I'm good. There are 1.248 moles of NO2. So what is the mass of 1.67 mole of calcium phosphate? So the first thing I need to do is I need to look at calcium phosphate in a second. 1.67 mole. To go from mole to mass, I need to use capital M. I need to figure out the capital M of this. So I look at my periodic table, and forgive me if my number's a little bit different from what you might have in front of me. I'm just using it off the internet. So I'm going to get 40.08 grams per mole, and you could be doing this work on a scrap sheet of paper. I don't need to see you doing it anymore. I'm going to get 2 times the mass of phosphorus, which is 30.97, and I'm going to get 8 times 16 grams per mole, and 16.00 grams per mole. Alright, so I'll do that math real quick here. 8 plus 30.97 plus 8 times 16 equals, so I got 230.02 grams per mole. So I'm free to use that over here, times 230.02 grams per mole. I could probably get rid of some of this. I don't need this anymore. That won't let me erase it. Oh well. Can't erase that, sadly. So I'll just do my math underneath. By the way, my moles cancel out, leaving me with only grams. 1.67 times 230.02 equals 384.1 grams. To give my final answer, 1, 2, 3 significant digits up here. 1, 2, 3, so I must write my answer with 3 significant digits, leaving me with 384 grams. Therefore, the mass is 384 grams. Awesome. Alright, so in this situation, how many moles are present in 28 grams of zinc? So I've got 20.0, sorry if I said 28 grams of zinc. Well, I'll look up the mass of zinc online here. Just give me a second. And I got zinc, and let's say I kind of misthink this, and I kind of say, okay, well, I'm going to multiply 65.39 grams per mole. This should be the moment where you kind of look at your units and you actually do some thinking. Grams on the top, grams on the top. With grams on the top and grams on the top, I'm not going to be able to cancel anything out, so this is obviously not going to work for me. So I'm going to need to rework this. So let's try that again. 20.0 grams divide by 65.39 grams per mole. Now my grams can cancel out because I have one on the top, one on the bottom. And I can keep mode right now. I can say that this equals 20 divided by 65.39, and I get 0.3059 moles. Look back at my question at the start, 1, 2, 3 significant digits. So when I do my therefore there are 0.306 mole of zinc atoms. Beautiful. What is the mass of carbon dioxide in a flask? So this one's good because I start all the way over at particles and I have to move eventually over to mass. And you can't do this directly. It's going to take a couple steps. So I start with 7.8 times 10 to the 22 particles. I know that I must divide by Avogadro's number. Particles per mole. My particles cancel out, one on the top, one on the bottom, which leaves me with 10.78 times 10 to the power 22 divided by 6.02 times 10 to the power 23 equals, I get 1 point, and I'm going to write 4 significant digits, 296 mole. Sorry if you can't really see things perfectly there, but that's okay. Now I've got 1.296 moles. I've got to get over to grams because that's what the final answer asked me to. And if you look at unit analysis, if you use or think about molar mass, you're not sure whether to divide or multiply. If I think about multiplying, just look at the units, and you know that moles are going to cancel out, leaving me with grams all by itself. So you know for sure you have to multiply and not divide. And that's how you can kind of start making those decisions. Carbon dioxide would be 12.01 plus 32 to get 44.01 times 1.296 equals, I get 57.04 grams. Now I have to look back. I have 2 significant digits, so I can round that now to just 57 grams. So the mass is 57 grams. Yippee. Okay. I'm going to kind of skip through these because I would like to get to example here. So let's look at what a mole of CH6O is made of. So if you had 1 mole of this, 1 mole of this particle right here, if you had 1 mole of this, you'd have 6.02 times 10 to the power of 23 of these molecules. But how many carbon atoms would you have? Well, you'd have 1 mole of carbon atoms. You would also have 6 moles of hydrogen atoms, because there's for every 1 particle there's 6 atoms, so it's a 1:6 ratio. And you have 1 mole of oxygen atoms as well. And then altogether, you'd have 8 moles of atoms total. And that shouldn't be too mind-blowing. The next step that happens here is if you have one single particle, well then you'd have 1 atom of carbon, 6 atoms of hydrogen, and 1 atom of oxygen for 8 atoms total. So for our final example here, let's look at this. I've got 5.0 moles of CO2, and I'm being asked how many atoms. So now I want to get rid of moles and work towards atoms. So let's work towards particles. So times 6.02 times 10 to the 23 particles per mole. So I end up getting in this situation is 3.01 times 10 to the 24 particles. Now I'm not at atoms yet because that tells me here that's my amount of moles of this whole molecule, okay? So let's just say it's 3.01 times 10 to the 24 molecules. And then we have to look in every one molecule how many total number of atoms. So it's not just one single one, but total atoms. So what's the total number of atoms in our particle here? 6. So we have 6 atoms per molecule. You'll notice our molecules cancel out. And I could say that there's a total of 1.806 times 10 to the 25 atoms. Sweet. Therefore, I look back 1, 2, 3 significant digits, so my answer will be therefore there are 1.81 times 10 to the 25 atoms.